In this part, we will focus on different functions from the tidyverse, or more specifically the dplyr package that can come in handy to manipulate your data before you use the ggplot package for plotting. One example is the filter function. So in some cases you maybe do not want to plot the whole data set but only parts of it, and then you can use the filter function on this data set. And here, for example, it is filtered for a sepal length greater or equal than 5 and at the same time a sepal width lower than 3.5. And here you can see the result. So it's a reduced data set which fulfills both of these conditions here. So with this function, it's really easy to filter your data. Here's another example. For example, if you want to only plot a certain species of the iris data set, only the Virginica ones, you can then also make a filter who compares the species column with Virginica and then only keeps this specific species. The mutate is also a very handy function. You can basically add columns to a data set that somehow depend on the already existing columns. So for example, here the mutate function, the iris data set, and then for example you want to log transform the sepal length, you can simply say, okay, I want to have a new column called log SL, which should be the log of the sepal length. So the column here of iris data set is referred to here. And on the same time, I also want a new column called PL plus PW, which is the sum of the petal length and the petal width. And then you can see that these two columns here are added to the original data set. And you can use them now in ggplot, for example, for plotting. Mutate works also really well in combination with the case when function. So this generates also new columns, but with rules based on values of other columns. So for example, it can be used to add categories. So for example, you want to have low, high, and middle based on the sepal width. Then you can just say, I want to save it in a column called SW level. You use the mutate function for this, and then instead of just like writing something, you use the case when function, and then you define the three cases. So if the sepal width is below or equal 3.1, you say it's low. If it's larger or equal than 3.5, you say it's high. And in all other cases, so this is what the true here means, in all other cases, so between 3.2 and 3.4, for example, you will say it's middle. And then it also gives here a new column with these categories calculated for each row separately. In other cases, you may want to summarize the data, for example, aggregate the data to have, for example, a mean value or something like this. And for this, you can use group by and summarize in combination. Here you can see again that summarize can be written with a Z or with an S. And you first start with the group by function. And here in this case, for example, you group the iris data set by the species. So it basically will make three groups, one for each species. And then within the summarize function, you will say again, I want to have a new column called SL mean, which should be the mean of the sepal length of this iris data set. And in this case, what is the output is a very small data set which gives you the mean value for each species. So here in the summarize function, you basically define what should be calculated, so the mean of the sepal length. And then with this group by, you basically define that it is not done on the whole data set, but for each group separately. And such small data sets, for example, can be used in ggplot to highlight the mean for example, in a box plot or something like this. So it may come in handy to know how to summarize the data. When we are talking about the tidyverse, you may see many people use it in combination with the so-called pipe, which is from the Margaret R package. It's a percentage sign, a greater sign, and a percentage sign again. And with this pipe, it is possible to apply different functions one by another to the same data set or object. So here in this example, we have x, which is a vector of 2 elements. And here, for example, I can calculate the absolute value of the log of x. This is how I would write this in base R, basically. But if you use the tidyverse style with pipes, you would write x is piped into the log function, and whatever comes out of it is piped into the abs function. This will give the same results, of course, but it depends how you look at it. So if you want to have the last function here as first, or if you want to start here from the inner to the outer function, basically. There's also a pipe in base R, but I think in a tidyverse still this pipe here is more common. And here's an example how you would use that for summarization. So instead of doing a group by, then outside of it doing the summarize, you can also just take the iris dataset, pipe it into the group by function. So you note here that you don't have to type iris again, but just say group by species, because it will know that it has to take the iris dataset from here. And then the result is then piped into the summarize function. So this may be a different way to write it. And you may see this kind of code in the solutions later also. So how to save the plots you have created? One really great advantage in ggplot is that you can save plots as objects and then change it later. For example, here you have, for example, this scatter plot here, and you save it in an object called PL, and then you realize, oh, I wanted to add a different theme, for example. You can just do it and just write PL plus the theme and save it in the next object, PL2. And the thing is that you have to keep in mind that the code is not evaluated at this point. So it's only evaluated when you call it here with PL2. Then the plot is plotted, and also errors that might occur will also become present here at this point. So it may be that you write a lot of code and you don't realize you make an error here, and then it only becomes apparent at the last step. And error messages and warnings will not appear before that. To save a plot into a file, you can use the ggsave function, and there you have the option to save it in different file types like PNG, PDF, SVG, TIFF, JPEG, and so on. So you just define the file name, which plot you want to save, for example, here in this case, the PL2 object, which device, so which type of file, the width and height of the plot, and then you can find here, for example, which units to use. In this case here it's centimeters, and you can also define a resolution in dpi. For the next more complicated exercises, you may also need help from outside. So there are a lot of help pages available for ggplot2. There are cheat sheets available which you can use as a reference. There are some free ebooks, for example, the R Graphics book or the ggplot2 book. It's also helpful to just Google your problem. Most likely you'll find an answer. For example, on Stack Overflow, we have over 57,000 questions that are tagged with ggplot2. So most likely someone else had the same problem before. And of course also artificial intelligence or large language models like ChatGPT can be helpful. For the next exercises, we will use the quantitative proteomics dataset, which you can find in the exercises data folder. It contains samples from 19 patients with hepatocellular carcinoma, or short HCC. And you have a paired design where you have 19 samples from the cancerous tissue and 19 non-tumorous tissue from the liver. Next to the quantitative proteomics data, this dataset also already contains the results from a differential analysis, so you have p-values and fold changes. And you have also an additional table with further information like age, gender, tumor staging, and so on. For this exercise part, please have a look at exercise 1.3.